Semiconductors are critical to the AI revolution, and our first panel of the day will discuss their development and importance. Please join me in welcoming Dr. Chris Miller, author of Chip War, The Fight for the World's Most Critical Technology, Dylan Patel, founder, CEO, and chief analyst at SemiAnalysis, and Vince Jesaitis, vice president and head of global government affairs at ARM. The conversation will be moderated by Stephen Witt, author of The Thinking Machine, The Story of Jensen Huang, and NVIDIA.
Yeah, okay, great. So I'm Stephen Witt. I'm moderating this panel on semiconductors and AI. Just a little bit about where we are right now. I was just asked to come see the Stargate project in Abilene, Texas, where OpenAI is building a massive $50 billion data center. So that's a mega project. And they're going to invest more in that than China invested in the Three Gorges Dam. It costs 10 times more than the James Webb Space Telescope. And that's one of 10 such facilities probably that they're planning. The total cost of investment will be larger than all 17 missions of the Apollo space program. So $500 billion just for that one company. Globally, it's in the trillions. So this is a new industrial revolution. And most of the money that's being spent is being spent on microchips. Most of the money is going to the semiconductor industry. Jensen Huang, the CEO of NVIDIA, has described it as a new industrial revolution. We're building AI factories where data goes in and intelligence comes out. So the panelists here are all sort of experts on this issue, and I'm going to just kind of go through and ask them various questions. And my first question, I think, is for Vince, who's at ARM, the British chip manufacturer. What's going on with this revolution, and like, what role does ARM play in it?
Thanks, that's a great question, and thanks for starting with Stargate. We were one of the founding technology partners of that project, and it's an absolutely just incredible project that is already under construction. There was a great documentary on it that came out about a week ago, and just to see the scale of this thing is just, it's unprecedented. ARM, we develop CPUs, we develop kind of the core computing that goes into all sorts of things, everything from your earbud up to data centers and projects like Stargate. And what we're seeing, I would say, in the semiconductor sector is just pushing out the ability to run AI on virtually any type of computing device. You know, I think it's probably underappreciated the amount of time it takes to design a chip, somewhere in the neighborhood of 3 to 4 years. So if you think about where we've come since that kind of ChatGPT moment in November 2022, really we're just seeing AI first chips hitting the market today because it takes that long to do the complex circuitry that goes into these things that are put together in the hundreds of thousands to go into a project like Stargate to enable that computing capability. But you know, there's two ways to think about it. I know some of you will know this. There's the training side of AI, which really requires this huge computing capability to train the models, to actually feed you intelligent information. And then there's inference, which is like, how do we all use AI? I would say ARM is kind of pervasive in the inference side of that. And as I said, everything from your earbuds to your smartphone to edge devices, your car, all the way up to the data center. So, you know, us, just like everybody in the semiconductor industry, is really thinking about how we optimize AI across every form of computing that we all use every day.
Yeah, usage demand is insane. Like ChatGPT has eclipsed Wikipedia. I think is the 5th or 6th most used website, and the demand curve is just vertical. Young people are starting to call it just chat, right? In the same way that we maybe said Google for internet search in the past. It's kind of just becoming this one thing. And that's just consumers. I mean, industrial demand is unbelievable. So building these data centers, it's all trying to get ahead of that demand. Chris is the author of Chip War. I don't know if you guys have read that book. It's the #1 book to read about kind of the geopolitical dynamics of this industry. It's really fun to read too. You wouldn't think that about a book about microchips, but it's just super compelling. And it came out though in October 2022. A lot of things have changed since then. And so Chris, my question to you is, what has changed since you published Chip War?
I think there are two big trends which have contradictory impacts for the US. One is the explosion in interest in AI, the huge demand for both data centers and also for edge devices processing AI. But the second is that the competition between the US and China has gotten even more intense, and China's capabilities have gotten better and better and better each year. And so we're simultaneously needing more and better semiconductors for AI, and also facing a competitive dynamic in which our lead has narrowed in almost every segment. Dylan's done some extraordinary work mapping Huawei's expansion in the GPU sector and building out their own AI servers, but in fact it's across the board, from foundational semiconductors used in automobiles and dishwashers all the way up to the leading edge in GPUs. China's position is better in terms of technology and more significant in terms of market share. And so we're becoming more reliant on chips for AI. We're also becoming more vulnerable to losing our edge technologically and to becoming more reliant on made in China technology for the future of AI that we're trying to build right now. And so for the US, it's a very dangerous, I think, moment that if we don't take steps to build and expand our lead, we could find ourselves relying on China for the AI capabilities that we're building our economy around.
Let me ask a quick follow-up. TSMC was really the bottleneck for kind of all chip manufacturing for a really long time, and specifically their facilities in Taiwan. Morris Chang, who for many years was the CEO and founder of TSMC, has called that the Silicon Shield. Like, China's not going to invade Taiwan, or this protects China from invading Taiwan because we've got all these manufacturing facilities here, and they'll tank the global economy if they invade. As these plants, fabrication plants, start to become more diffuse and spread out to sites around the world, does that Silicon Shield begin to disappear?
I think if you ask yourself, who's playing the biggest role in undermining the Silicon Shield? There's a lot of discussion, especially in Taiwan, about the TSMC plants in Arizona. But ask yourself this, who's de-risking faster from Taiwan? It's obviously China. China's self-sufficiency drive is vastly more impactful than our own. China's building far more fabs than we are. China's market share in almost every segment of the chip industry has grown dramatically. And China's doing that precisely so that if there is a disruption, which they create, the Taiwan Straits, they'll be more insulated than we are. Now, they're still not self-sufficient, but they're a lot closer to self-sufficiency now than they were just a couple of years ago. And look at the spending trends. China's spending more than anyone else, subsidizing their fabrication build out. And so we should expect in 5 years' time, they will be even closer to self-sufficiency then. I worry that that's actually the erosion of the Silicon Shield that we should be worried about.
Okay. Dylan is really knows the nuts and bolts of this as well as almost anybody. So I wanted to ask you, what would it take for China to build a competing kind of like AI stack? You know, fabrication, data centers, everything. Is China getting close? What do you see happening there?
So I think following on to Chris's comments, right? Like TSMC making an announcement about $100 billion in the US doesn't build AI in the US, right? Those fabs are paperweights for 4 years because they have to build the shells. And then they move in the tools, right? So the Trump administration is gone and they can renege on their deal, very likely, a high possibility. Furthermore, that only gets you like one of the chips that are on an AI system, right? An AI system has hundreds of different kinds of chips, right? Yes, the big sexy, 5 nanometer, 3 nanometer, 2 nanometer, that's the sexy one. But there's all these other power ICs, there's all these other analog ICs, there's all these networking chips that are not made in, never gonna be made in those fabs in Arizona. And so I think, when you talk about the erosion of the Silicon Shield, it's like, no matter every fab that's been announced in the US, we're still not going to be able to make cars in the US without chips from Taiwan, right? Or AI servers, or really anything. And as far as like what is China doing, it's really, as Chris said, right? They have a self-sufficiency drive that, hey, actually they have power semi, RF semi, as well as trying to push into the leading edge. And yes, they're further behind on that, right? Just getting to 7 nanometer, although despite US restrictions that are quite ineffective in terms of enforcement, they are building rapidly, right? And I think the number one thing to always think about is, no, China is not a decade behind. They're not 5 years behind. They're much closer than that on every metric. And anyone who says they're further than that behind is just completely wrong on semiconductors. And this is through both self-sufficiency as well as importing foreign tools, foreign wafers, which are still allowed, right? Or circumventing export restrictions. So they're doing everything possible while we're playing 3D chess while we're just playing checkers. And it's really quite clear that they will be able to make millions of AI chips domestically, right, next year, right? Not the US. The US won't be able to do that.
Yeah. NVIDIA was selling its kind of modified chips into China, but they enforced this recent ban, and NVIDIA had to take a $5 billion write-down on this unsellable equipment. Jensen has argued that this ban is counterproductive because 50% of AI researchers are in China, and if you restrict the US from being able to sell its chips into China, this actually helps them build a domestic industry. What do you make of that argument? Is it true?
I mean, like, anytime someone says a ban of US stuff to China helps them, is kind of like, okay, then they would just ban it themselves, right? Like, obviously it doesn't help them. It helps them build up it does let them like build up their own domestic industry more, but that was happening regardless, right? And they've already committed to hundreds of billions of dollars of subsidies, and they've already spent well over $100 billion in subsidies from government, SOEs, et cetera, on the semiconductor industry. This drive was already there. It's happened in industries where we didn't ban them. The question is what happens when it's an industry where we did ban them, right? And then as far as like, is this good or not, right, is really, what is your timeline on AI for making a real impact in the world, right? In the economy, in military, et cetera, right? It's already impacting like the tech world dramatically, but what about the rest of the parts of the economy? And if AI is here to change the world in 3 to 5 years, then this ban is absolutely necessary. Otherwise, China will become the global hegemony in 3 to 5 years, right? The US sort of needs to maintain that. Now, if it's like 10 years, then this is absolutely counterproductive because now, again, China's gonna have a self-sufficient ecosystem, and then they'll start exporting it eventually. They have no capability to export AI chip semiconductors over the next few years, but eventually they'll start exporting them. So that's NVIDIA's biggest fear. They're not afraid of, Google TPUs. They're not afraid of AMD. They're afraid of Huawei doing what they did in telecom, which is out-competing everyone, right? Because Huawei has that capability.
Yeah, definitely. I've noticed that fear in my conversations with Jensen myself. Chris, what do you think? Is this, can they build it up? Can they get like the ASML machines in there? Can they smuggle what they need? Can they build domestic capacity? Like, how do they do it, and what's the risk?
I think what we've learned over the last couple of years is about the huge loopholes in the US export controls. There's been a big debate in the US, export controls good or bad, but I think one of the key stories is export controls not really enforced. And again, I think SemiAnalysis has been key to our understanding of this. Many of you probably seen the satellite photos of 2 fabs next to each other, one of which you can sell advanced tools to, one of which you can't sell them to, and in theory they're separate fabs. You can see in the satellite photos the wafer bridges connecting them.
Yeah.
There's a Swiss cheese-like approach that we've adopted for export controls, and I sympathize with US companies when they say, well, wait a minute, our competitors can sell this, we can't sell that, and it seems like enforcement has been one of our absolutely key challenges, both because it's a little bit complicated to enforce, but also because we haven't had the political will to really enforce seriously. And one of the big questions the Trump administration faces is, are you actually going to do enforcement or not?
Yeah, Vince, in Singapore, they recently busted a reselling ring for NVIDIA equipment. So they were smuggling, basically notionally selling this stuff to like Malaysia, and then these guys would just flip it back into China, which is very hard to control against. And I believe it was, I can't remember the name of the US legislator who's proposed a bill to actually put tracking devices on all of the kind of semiconductors. I mean, you have to navigate this at ARM because you're making some of these components. How do you think about this? I mean, should these devices have tracking devices on them?
Yeah, it was, I believe there were actually a couple bills, Congressman Bill Foster in the House and Senator Cotton in the Senate.
Oh, it's Cotton, that's right.
Yeah. Look, I mean, there's kind of 3 key ingredients to AI. It's compute capacity, it's energy, and it's talent. 50% of the AI developers are in China, approximately. I think we understand what they're doing on the energy side, right? Like the Stargate project is 1.2 gigawatts of power is what they're expecting it to consume. That's equivalent to about a nuclear facility dedicated specifically to that specific infrastructure project. So they've got the first 2 pieces. On the compute side, it's incredibly complex. As Chris said, export controls, they are a tool, but they're not the tool. Tracking devices, in theory, they're good. You just have to wonder, with a nation state actor with the capability that China has, do we really think that there's kind of a technological solution to be able to track these things? Like, it really, I think, the idea conceptually is a good one. When you actually think about how you implement it and how you create the technology that would allow you to actually know where these things go and not be manipulated by, by a bad actor, it kind of breaks apart, at least what we've seen so far. There have been a number of papers put out on it, and the industry is looking at it. We had a meeting last week amongst the industry on kind of, is this viable? Is this, a tool that we could use? Kind of the solutions that we've seen that are already in the market probably aren't going to do the job for something that's as strategic as semiconductors.
I mean, what does the ideal kind of what are you pushing for in terms of legislation now? What does the ideal landscape look like for a chip manufacturer like ARM or NVIDIA? Given that, inside China, they're essentially trying to rebuild what you do. Do you want them as customers or not?
I mean, I think Jensen has it right. It's an incredibly huge market, right? It's
Sure.
the biggest semiconductor market in the world. We understand as an industry the sensitivity of what we do and the applications it can be used for and why there need to be controls. Export controls are obviously not a perfect tool, but that's the tool that the US government has really focused on. I've seen some folks from the Semiconductor Industry Association around here who we all work with. I think we're all putting our heads together on what the right tools are. But we're in an unprecedented era, and the tools that we had from the Cold War are probably not going to be useful in this domain.
If you guys get the chance, the Marines are over here, and they have a kamikaze drone that will fly into targets and people and objects. And it took them a long time to actually build and deploy this, and the bottleneck was that none of the chips could be made in China. Nothing in it, no component could be made in China. And so I think there's only one provider out of El Segundo that can now finally do this. It's very similar to what we just saw deployed in Russia by Ukraine. So get a chance to go look at it. It's kind of mind-blowing, actually. I lost my train of thought. Chris, what was I going to ask?
Could I pick up on the question you asked?
Sure.
Us? Actually, what's the policy landscape that we ought to want to have? I think we've had a lot of debate about export controls.
Yeah.
Everyone's got a view. Some are more informed than others, but we've spent a lot less time talking about is the promote side,
Yeah.
which I think in the long run is actually the more important side. What we've learned from China is that if China can produce at a roughly comparable level of technology, it will immediately stop importing any sort of foreign products.
Yeah.
It's done that in autos. It's done that in every segment of manufacturing except for semis, semi-manufacturing equipment, and jet engines. China's a net exporter of every other type of manufactured good.
Yeah.
And so the only long-run strategy is to stay ahead.
Yeah.
And I think the question we don't ask ourselves enough is what are the policy tools that would let us stay ahead? I think tax credits for R&D, I think immigration that lets us attract the best researchers around the world, and making sure we're funding the next generation technologies. This is even more important than export controls, although I'm a supporter of the export controls that have been in place thus far. And I'm always struck in Washington, there's twice as much, 4 times as much focus on the control side as there is on the promote side, and I think that gets it exactly backwards.
Yeah. Kind of a free-form question, but what happens to this industry and to this kind of AI revolution if China does invade? Like right now, let's say that happened. How disruptive would that be? How many years behind would we suddenly be? I was talking to people in Taiwan recently. I said, what would happen if they started sending the boats? And they're like, we'd smash up all these machines with baseball bats. We'd destroy this stuff rather than let it fall into their hands. Amazingly, it seems to me that the industry has not done that much contingency planning about this event. So what do you think that would look like to the global economy, to the semiconductor economy?
It'd be very bad. It'd be catastrophic. And there's a lot of discussion in the US of if something bad happens in Taiwan, will we take out the fabs? And it's worth reminding ourselves, those fabs produce chips for Apple, for NVIDIA, for our cars, for our dishwashers, for our coffee makers, for our medical devices. It would be catastrophic for the US first and foremost. And this gets back to why it's so dangerous that China is de-risking much more rapidly than we are. Because China's setting up a circumstance, we'll be pretty close to it in a couple of years, where China's not that impacted, except at the most leading edge, by a cutoff of Taiwan, and we're hugely impacted. And that's a very destabilizing dynamic from a geopolitical perspective.
Dylan, when I talk to NVIDIA, they say our edge is not really in microchip fabrication or design. They say, really it's software. We have all these software products on top of our chips, and this is what makes us hard to compete against. how hard is that to rebuild?
I think first off, I think that's a nice story, but it's objectively false that their edge is not designing chips. Like AMD's great at designing chips, but their competing product, MI300X, cost 2.2x more than a Hopper NVIDIA H100 and performs roughly equivalent, right? And yes, a lot of that is because of software. Actually, in most cases, it performs worse because the software sucks, right? But in cases where like Meta or Microsoft spend hundreds of engineers making it work, then the performance is similar, right? So it's that like, even once you work on all this software stuff and you spend a lot of time hand coding on really low level, not through like say a layer high up like through PyTorch, but like something very low level, more assembly like, and you get all the performance out of the hardware. NVIDIA's hardware is still way better than AMD's, right? So I think that's one thing. But as far as like the software side of the story,
can Huawei build that?
I think the argument is there's always going to be engineers who can go at a super low level, right? And if you go look at what DeepSeek did, they programmed NVIDIA GPUs at extremely low level. You go look at how many graduates come out of US universities with understandings of assembly or computer engineering, very low-level architecture. It's far less, especially once you say, well, more than half of them are actually Chinese, but like, so let them stay, please. But like, in China, they have significantly more, right? Firmware engineers, low-level programmers, they can hand code a lot more, right? Like this advantage on software for NVIDIA is really about helping development velocity for understaffed, labs that only have like, 1,000 people or so that are doing the research at like OpenAI and Anthropic, right? When you have tens of thousands of engineers who can do really low level, high performance code, it's a different equation. Yes, this software matters, but not that many people, no company can justify that because of the pace that things are moving at. But as far as like, can they replicate it? They have a software stack. It's okay, it's upstreamed, you can actually like access it, look at it, it's like fine, right? It's not amazing. NVIDIA's is obviously way better. And it's going to be really hard, right? Like NVIDIA's advantage, right? Like part of the argument that I think NVIDIA doesn't really make is that like some of the best open source software comes from China, right? ByteDance open source is awesome NVIDIA software all the time, right? Like built on top of NVIDIA libraries, and then other people turn around and use that, right? And many other like Chinese universities like Tsinghua open sources tons of great software on top of NVIDIA GPUs. There's millions of developers around the world that are building on top of NVIDIA GPUs, and that then becomes NVIDIA's moat on software. Because it doesn't transfer to anyone else's hardware.
I think I'm going to open the floor to questions if anybody has any. So the mic's right there.
Hello, my name is John Wetzel. I am at a Massachusetts Economic Development Agency and here with the NEMC Hub, which is a microelectronics commons funded organization. My question has to do with what role do you believe that the state infrastructure plays in trying to build that competitive moat. Obviously, a lot of our funding came from DoD, implications to try and figure out how do we scale microelectronics from laboratory to fabrication and solving that really hard problem. Are there other areas that you believe that state should be playing there, either on investment and subsidization or in enforcement roles, which historically haven't been translated down to the state level?
I can jump in and use Stargate as an example. Refer back earlier to the three kind of ingredients that I was mentioning you need to really accelerate AI. It's compute, it's energy, and it's people. And around Stargate, the city of Abilene and the state of Texas, all the way up to the governor, have really been instrumental in making sure that things can move quickly. We can have access to the energy that we need. We're able to get the permits we need to deploy that facility, and both the physical facility, but also the additional energy we're going to need to produce. And the state of Texas has done a great job on the educational side as well. I mean, they've got amazing programs all the way up from kind of skilled workers you would need to construct these facilities to double electrical engineers that we would hire in our workforce to actually design the circuitry on these chips. So yes, there's absolutely a role for the states. Other states have done Really great work as well, but I would just highlight that because we have kind of the most experience working with them holistically recently.
I would just add that, like, on maybe a more pessimistic view, here's very optimistic, is that a lot of the build-outs in the US are significantly constrained by government. It's not assisted by, right? To build a fab, for example, CSET has some awesome research on this, right? It takes a couple hundred more days in the US than it does in Japan and Taiwan and China, right? To build a data center, there's humongous queues for interconnection requests. It's like you have to request the utility to like interconnect into the grid, and the queue is like years long because the utility is like, I don't feel like it, or I don't like want to dramatically expand my workforce because I'm a local monopoly, right? And it's like, why are we allowing this local monopoly to do this and slow us down, right? There's all these things around water rights, right? Like alfalfa farming is a much better, use of water, wasting like 40-60% of the water in Arizona versus like 1% which goes to like a data center that's generating billions of dollars of value, or a fab that's generating billions of dollars of value. So I think it's like the allocation of these resources and also the training of the people, right? We just don't have enough skilled tradespeople to build these things fast enough. Abilene is amazing, but for every Abilene and the progress that they're making, there's dozens of data centers I could tell you about all over the US that are behind schedule, right? So I think, and that's because there's not enough tradespeople, and the same applies to fabs.
Next question.
Thank you very much. This is Ziad Zimbaya, Senior Advisor at the Harris Jackson Policy and Technology, also Fletcher School. I have a question to Chris, and if anyone else wants to answer. What's Russia's current ability to acquire in ways that they do, or steal or smuggle advanced chips for their weapons, especially as it relates to Ukraine?
Well, so far as we can tell, and we get a fair amount of data now thanks to teardowns that Ukrainians have done, Russia's ability is very strong. They've smuggled in very large volumes of chips. I think most of the media attention is focused on Kyrgyzstan or Turkey, but it's all China. China's 90% of the chip smuggling. There's good data on this going into Russia. And one of the failures of the US and of Europe thus far is failing to put pressure on China to crack down on this. And so we still find Russian weapon systems with chips produced post-2022 landing or being captured in Ukraine. I think this is a real failing of Western policy.
Next question.
Yes, hi, gentlemen. I invest in semiconductors and private equity and venture capital. Can you characterize how Amazon or AWS, Google, Oracle, IBM, those players who have come out with their own chips, let's take AWS, for example, the train chip set, how does that compare? Are they picking up the lower end of the compute market, and NVIDIA still picks up that high, deep end? How does it fit into the world?
Dylan?
I think there's a misnomer that there is a low end of the AI compute market. These AI workloads are large workloads that you batch, right? You aggregate hundreds of users and you put them together. There is really no reason to do a low-end AI chip in a data center, right? It makes sense to put these lower-end AI chips in cars or on the edge, right? There's power constraints, all these things. But when it comes to deploying AI infrastructure for large-scale deployment, whether it's for your cloud customers or services, you have such traffic volume that you just batch all these requests onto high-end servers because those are the highest cost efficiency, right? The reason NVIDIA's, and Jensen often says this, right? I could give the last generation of chips away for free and no one would do it.
Yeah, I mean, they had to write down the $5 billion in compromised Chinese chips that they meant to sell. There's no secondary customer.
Right, because everyone wants the new one, because the new one is not 2x better, it's not 4x better, it's 10 to 15x better performance for only 2x more cost, right? And so there's this dramatic difference in performance. And as far as like, what is Amazon doing? What is Google doing? Google's chips are great, and they use them internally a lot, and all their services, search, everything, right? DeepMind, all the Gemini models. Amazon is hopeful to get there. They're mostly doing like low margin deals, or deals with Anthropic that are effectively their own money round tripping, right? They hope to get there one day where their chips are good, really good and useful everywhere. But today they have to buy their own market, right? By getting Anthropic to use the majority of the ones that they're, or dog fooding them internally. But as far as like the others, right, like Metas are great for their own recommendation systems, right, but they're not great for, generative AI. So it's like everyone is trying because NVIDIA's margins are really high. They would like to reduce that. They would like to have their own internal tech stack that they control. But NVIDIA is racing ahead very fast.
Right, I mean, if Google makes a great TPU, are they going to use it for Gemini, or are they going to sell it to their competitor? They're not going to sell it to their competitor, right? It doesn't make sense for them to do that. If they've got some kind of competitive advantage, they're just going to keep it in-house to power Gemini. NVIDIA doesn't have that problem, right? They're platform agnostic.
Although you look at Google's market cap, you look at NVIDIA's market cap, maybe they should sell this thing, you know?
Yeah. We probably have time for one more question.
Hi, my name is Raghav. I'm a student at Georgetown University School of Foreign Service. So you mentioned that enforcement was one of the main deficiencies with export controls, and some responses to the AI action plan recommended like an interagency task force for enforcement. So I'm wondering what like your visions are for a robust enforcement model for export controls and whatever ends up replacing the diffusion rule.
It's amazing how like just what a free-for-all it is. I remember like I was writing this story about people, Iranian agents who were coming to America and they were buying the controllers for ICBMs off like the secondary market and then shipping them back to Iran, which is like, you would think that's impossible, but there's almost no enforcement at all. It's crazy, so it's a great question. Let me throw it to Chris, I guess.
So I think an insightful comparison is to look at enforcement for financial sanctions versus tech export controls. So financial sanctions, the fines are often in the many billions of dollars. And the US has enforced repeatedly multi-billion-dollar fines on international banks, not just US, but European banks, Asian banks. And as a result, banks know there is a very, very high cost for even a single transaction with a sanctioned party, and they rationally invest hundreds of millions of dollars of their own money to set up their own enforcement arms. Turn to the chip sector. The largest penalty ever paid was $300 million, so an order of magnitude below the standard penalties for financial sanctions, and that was a one-off. I think unless you start seeing much higher penalties for enforcement violations, companies will rationally underinvest in compliance, which creates a real problem, both because the US government then has to do all the enforcement itself, and it can't do it for the reasons you alluded to, and it penalizes the companies that are doing the right thing and setting up effective compliance arms because they're suffering a cost burden for doing that and their competitors aren't. So I think we need higher penalties to induce more compliance spending by customers and actually create a level playing field where the companies that are underinvesting don't benefit relative to their peers who are doing the right thing.
And Vince, I imagine you have a slightly different perspective on this question?
No, Arm is one of the good guys. Arm is one of the good guys.
I think that's a good one, and I know it's not a great time in DC to say we need to spend more, but BIS is the Export Control Enforcement Agency at the Department of Commerce. It needs more resources. It needs people in markets where a lot of these products end up. It's a two-way street. We work with them hand in glove. They can really be eyes for the industry in ways that we wouldn't even think or know to look for. So they need more resourcing. They need more people in the fields, and then I would just second everything Chris said.
Okay.
So.
Well, listen, thank you all for showing up and attending the panel. On behalf of the panelists and everyone else, it's great to be here at SCSP's AI Plus Expo. I'm going to be signing books at 1 p.m. in the bookstore if anyone wants to stop by. And thank you so much.